Aging affects all of us, and unfortunately the image of older people sitting idle in nursing homes like this is all too familiar. Scenes like this are symptomatic of a much bigger problem, and that is a chronic shortage of frontline workers. Globally, we need another 7 million healthcare workers just to meet demand, and this number is set to grow to 15 million by 2030. The only sustainable way to overcome this problem is through the development and more effective use of technology. We need technology that empowers older people and the critical frontline workers in the sector. There's truly no other way. Well, much of the technology we need is actually out there. Integrating it creates many practical challenges, especially in nursing homes and senior care settings. Issues like who is responsible for the technology? Who does the software updates? What happens if something breaks? What happens if the person who's trained to use the technology leaves the job and no one else knows how to use it? All of this means that even if the technology does exist, because it is difficult to integrate, it simply doesn't get adopted. My name is Conor McGinn, and for the past 10 years, I've been researching in robotics and artificial intelligence, not only on the technical side, trying to understand how we can build advanced technology that can be useful, but also figuring out how can we put it in the hands of users who can make best use of it. In 2014, my research group and I had an idea for how to address this problem. Instead of developing lots of separate pieces of technology, why not just make one? An organization might pay for it through a service contract. This will give them peace of mind that if something was to break, that it could be handled by someone else. With our artificial intelligence, over time, it could get better and new applications could be added all the time, making it more and more applicable in that scenario. And it wouldn't just be targeted at the frontline staff. Older people may also be able to benefit from it, to extend their independence and also improve their quality of life. And the best part about it, it can be simple to use. Actually, not just simple, the very experience of interacting with it in itself could be fulfilling. And it was this idea that formulated the idea of Stevie. In 2017, a few years later, we got to a point where we could actually build and test such a solution. This was a social robot that my team and I developed, and really it was designed as a piece of technology that was both easy to use, and you spoke to it simply the way you would a normal person, but it could also perform a wide range of tasks, depending on the time of day and depending on the setting it was being used. We didn't just build this alone as well. We worked closely with a number of charities, including Alone here in Dublin. After we launched it, it completely took off. Photographers and journalists started attending our outreach activities, normally that would be pretty low-key affairs. We started getting invited, actually the robots started getting invited to all kinds of events, and we even did some TV shows. And we found that the technology wasn't just for older people. All age groups engaged with it. And for the next 18 months, we spent developing a new and better Stevie. This upgraded version ended up being slicker, sturdy, more expressive, and had a range of applications which meant that we could hit the ground running when we tested it in long-term care settings. And even more so than before, we built it in close cooperation with the people who we wanted to see using it. That was the residents and care of senior care facilities. And there was 3 core applications we focused on in particular. In the first application, we looked at how Stevie could connect people through video calling. Even though apps like Skype and FaceTime were known to many older people and many residents we spoke with, they were seldom used. During our pilot, we found that when people used Stevie to contact their relatives, it was a really enjoyable experience. And they found that the experience really easy to use, and it left people asking when they could do it again. In the second application, we looked at how Stevie could help people with cognitive impairments like dementia or Alzheimer's. It was common that people would come to us and actually give us scenarios whereby they knew people with dementia, knew people with Alzheimer's. It wasn't just the engineering team that volunteered it. By working with these people, we were able to create scenarios where Stevie did things like reading stories and playing music to residents. And this functionality seemed to have a really positive effect on their well-being. Not only that, we found it actually freed up care staff as well. Care staff were coming up to us saying that this was an amazing piece of technology that they could see being used every day there. In the third application we looked at, we tested Stevie's ability to lead group well-being activities. These activities play a critical role in the everyday lives of many residents, can place significant pressure on staff who have to at once be the MC, while as well being able to give one-on-one care when needed to certain individuals. And every day for 3 months, just like you see here, Stevie used to hold court. His events became so popular that sometimes we actually have to turn people away. All in all, in 2019, Stevie spent nearly 4 months in settings like this, in both the US and Washington DC, as well as in the UK, in the region of Cornwall. During our trials in the US, a journalist from Time magazine stopped by for a few days to see what all the fuss was about. Her experience during this period was captured in an article she wrote for the magazine. And about this time of last year, Stevie featured on the cover of the prestigious publication. In the months to follow, though, it may not be what most people would have expected. Initially, things went really well, and the team spun out a company as we felt that this would allow for us to move faster and ultimately affect more people. We generated a lot of interest from all over the world, and actually the pipeline of organizations that wanted to work with us and have a Stevie at the facility. But just then, when things seemed to be going too well, we completed the design for the new robot, and we're on the verge of agreeing a number of different pilots for the summer of 2020, then COVID happened. And we knew that this was serious. By the end of February, we realized that this was a huge problem. And the first issue was that visitor restrictions were going to be brought upon us. And this meant that we would not be able to, we, the engineering team and the design team, we wouldn't be able to spend time at the facilities. And this was a critical ingredient to our success in the past, and now it was going to be gone. Furthermore, one of Stevie's biggest benefits was that it became a catalyst for creating serendipitous interactions between groups of people. And now, as nursing homes across the world went into lockdown, promoting social interactions became a pretty low priority, and something that might actually be discouraged for the fear of the potential breakout. Fortunately, though, we had a plan B. As it happens, months earlier, we had seen firsthand the problems that infectious diseases have in long-term care settings. Infections of various types routinely cause older people to become hospitalized or even worse. And around this time, we noticed that the New York Times ran a piece which claimed that the conditions in nursing homes created a breeding ground for germs. We know with the spread of germs like the coronavirus, they can be minimized by the spread of masks and following hygiene practices that include hand washing. The final line of defense, though, is disinfection. This is when we go into and we actually kill germs in the room, normally through the application of chemical agents. And this is extremely difficult to implement in nursing homes, and as we learned, also in hospitals. And in fact, the techniques we use now, they haven't changed in over 100 years. Our approach to disinfection remains the same as it was before the Spanish flu pandemic. The Washington Post referred to this method as Grandma's method, and it's extremely limited. To get a sense, look around the room that you're in right now. See all the surfaces that are there. How long do you think it would take you to wipe all of them down? Now imagine doing that, not just in the room, but in the building you're in. And not just once, you need to do it multiple times a day, indefinitely. So it's for, it can go on indefinitely. And we know that germs too are invisible. So even after you've done all of this work, you can never be sure that they're all gone. Even when you have done it, you haven't done any of the air. So you've actually only disinfected a small proportion of the room where these germs might lie. It is possible that you can vaporize chemicals and that could go into the room, but this could take hours to prepare the room, and it means then that you have to evacuate it. And this is rarely practical. And germs can also develop immunity to chemicals over time. So this means that harsher and harsher chemicals need to be used, which can be extremely toxic to the well-being of the cleaners as well as the environment. Luckily, though, there's hope, and it comes in the form of UV light. At certain wavelengths, UV has been shown to be extremely effective at inactivating microbes. And unlike chemical-based cleaning, germs can't build an immunity to it. And the light doesn't just kill germs on surfaces, it works on the air as well. And since the light irradiates in many directions, it covers a very large space. So it can be used to clean in a fraction of the time that would normally take people. It can also work on fabrics. So this means it can be applied on public transport, planes, and many other non-clinical settings, including nursing homes. This also isn't a new method. It has been used for nearly 50 years, and there's a massive body of literature supporting its effectiveness. And it seemed to us more than a year ago at this point that combining this technology with robots presented the ideal fit. It provided something that could be scaled. It was something that could be applied in many different settings, and it could be provided in a way in which cleaning teams could be kept at a distance, keeping them safe. And in March 2020, when we had this idea, we went to the HSE and we asked them if this could fit. We asked them if they felt that would this be something that they think that could help during a time of COVID. And with the support of Martin Curley and his team in the digital transformation department, we were able to build a prototype and actually test this idea in a hospital in just a couple of weeks. And in just a couple of weeks, we were actually able to validate this in a real hospital setting. What you see here is a beta prototype of our robot Violet, which is autonomously navigating to different waypoints in the room and irradiating the surfaces and air as it goes. These locations were determined from consultation with microbiology and infection control experts, who were able to estimate the areas where were most likely for people to have touched in recent times, in which case we'd expect to see high concentrations of microorganisms. We did a program of swab testing, which allowed us to show that after the radiation, we were able to measurably reduce the presence of microbes to a level that's as good, if not better, than what was being done with human cleaners. What makes this solution even better is the fact that it's actually able to work alongside human cleaners and human workers. This means in a setting like radiology, where time is everything, the radiographers or cleaners are actually able to prepare the room for the next patient or do cleaning, as you see in this video, while Violet's still present. And this overcomes a big limitation of current UV robots that require the room to be evacuated during use. I was asked last year, soon after the Time magazine cover came out, how a small Irish team had managed to do so much. And at the time, I really wasn't sure how to answer that question. And I'm still not sure how we managed to get the publicity we've received. But I do know that we're not a small team. What we've created has emerged from many years' work that has involved many, many people, only some of whom are shown in the slide. And that number is still growing. Our team is also more than just the people who've worked on this in Trinity and more recently in Akara. Our team comprises all of the partners, all of the organizations that have helped us over the years and at present. Our staff and these people who are working with us have made tremendous sacrifices to get us where we are, and we're just so grateful. We're especially grateful at the moment to the HSE and the Midlands Regional Hospital in Tullamore for all of their ongoing support and assistance over the past few months. We're also being supported by SFI, who are enabling us to continue our research. And we're working closely with the microbiology department in Trinity, as well as colleagues in the ADAPT Research Centre, which is allowing us to develop a system that is both effective against germs, but also very, very easy to use by the people who need it most. And this work also wouldn't have been possible without the support of the Digital Hub, who've helped us enormously throughout the pandemic. I'm pleased to say that the development is finished on our new robot. Violet 2 is coming out very shortly. At the moment, we're testing it in Tullamore Hospital and the results look extremely promising. We look forward to sharing these results with you shortly. Please stay safe.